So hello, my name is Ben Watkins. I'm an assistant professor at Aflac Cancer and Blood Disorders Center, Children's Healthcare of Atlanta, and Emory University in Atlanta, Georgia. So I'm going to be discussing how day 100 transcriptomics can help predict the development of chronic GvHD. So chronic GvHD remains one of the primary causes of long-term morbidity and mortality after transplant. So while there have been breakthroughs in the identification and implementation of biomarkers with prognostic and diagnostic significance for acute GvHD, there remains a significant need for chronic GvHD. So to help address these needs, we created a model in which we analyze CD4 T-cell transcriptomics at day 100 in patients that developed chronic GvHD and compared them to patients that had an absence of disease. So we decided to eliminate the potential confounder of prior steroid use. So we focused on patients that had de novo chronic GvHD with no prior acute GvHD and compared these patients to patients that had operational tolerance, which are those patients that had neither acute or chronic graft versus host disease that required steroids. So day 100 represented the ideal time point to study, as this is often the inflection point between acute and chronic GvHD, and is often the time which immunosuppression is weaned. So we began our analysis by performing differential expression analysis, and not unsurprisingly, we saw many genes that were differentially expressed between the groups. In patients with chronic GvHD, we found a prominent naive T-cell signature that recapitulated what we saw with the flow cytometry, with a significant increase in naive T-cell populations in patients with chronic GvHD compared to operationally tolerant patients. We also found several genes that have been identified in T-cell activation, including NLRP6, which encodes an important inflammasome protein that is highly expressed in the intestinal epithelium and has been previously implicated in a pathogenic role in graft versus host disease. We also saw several type 1 interferon genes whose expression is associated with STAT3 activation and has been previously implicated in graft versus host disease. Gene set enrichment analysis, or GSEA, further strengthened our conclusions for the DE analysis, with the top GSEA hits again being linked to that JAK-STAT pathway and type 1 interferon responses. Our operationally tolerant patients had a very different transcriptomic signature, as we would have expected. One of the things that was most striking was the increased heterogeneity in the pathways and cell states in the operationally tolerant patients. Some of the most prominent were memory signatures, both in conventional CD4 T cells and memory Tregs. We also found many genes associated with T cell quiescence. Thus, in contrast to the naive and activation pathways that dominated the CD4 T cells in patients with de novo chronic GvHD, the operationally tolerant patients had a more complex pathway structure that included expression of more regulatory and T cell quiescent genes. This study helped identify pathways that warrant further interrogation, including NLRP6 and STAT3, and suggests that naive CD4 T cells may represent a reservoir for alloreactivity, and strategies aimed at restraining naive CD4 T cell pathogenic activation after day 100 may improve chronic GvHD outcomes. We're now using single-cell RNA-seq studies to help deconvolute the cell types and states that are driving chronic GvHD. Thank you.